x-axis for 0.8 and look where they intersect. So negative 1.6 intersects with 0.08 at 0.0456. So your probability of negative 1.68 is 0.0465. And then you can look in the positive table. So remember that we have two tables, we have the negative and the positive table. So for 1.34, you look along your y-axis first for your 1.3, and then you look along your x-axis for your 0.04, and we try to see where they meet. So 1.3 intersects 0.04 at 0.9009. So these are the values that we got for the probability when z is less than 1.34 is equal to 0.9099 minus 0.0465, which is the probability when z is less than negative 1.68. Again, we can represent this on a graph. So this represents our z value of negative 1.68 over mean of 0, right? And then we have another z value of 1.34, our center is 0, and we have another z value of 1.34, and the probability is of the shaded area should be 0.8634. So what we just looked at was forward problems. So this is where we're given the x and we need to find the probability. So as we did before, step 1, we converted x is equal to x where z is equal to, then we found the probability. So from the standard normal table, so we standardized our x values, then we found the probability of the z values from our standardized values from the normal table, and that's the problem. Now, let's look at our backward problems. So, given a probability, so suppose you're given a probability and you want to find the value of x. So the first thing is that we have to ensure that we have the less than sign in the probability. If not, we have to convert the probability to that format first. Step the standard normal table from inside to outside, that is, look given probability in the body of the table, then identify the z-score which corresponds to that probability. And then step 3 is convert the z-score found in step 2 to x using the formula x is equal to the standard deviation times z plus the mean. So we're going to use a question for that. So it says foot length in inches of a randomly chosen adult male is a normal random variable with a mean of 11 and a standard deviation of 1.5. Suppose that an extra large socks is designed to fit the largest 30% of men's feet. What is the smallest foot length that fits an extra large socks? The first thing we have to do is write down what we're given. How did we know that this was a backward problem? They didn't give us, the fact that they gave us the percentage, they gave us the mean, they gave us the standard deviation, but they didn't give us the X value of interest. So you're going to write down what you were given. So we know that the mean is 11 and the standard deviation is 1.5. So the extra large socks is designed to fit the largest 30% of men's feet. But we need to find the smallest foot length that fits an extra large socks. How do we do that? In order to find that, we know, because we know that the 30% accounts for the largest, to find the smallest, we have to use the smallest will represent the 70%. Remember that the sum of all our probabilities must be equal to 1. So how did I get the 70? All I did was minus 30 from 1, 0.3 from 1, or you could say 1% from 100%, and I got the 70%. Since we're doing a back problem, the first thing we have to do is find out the probability that we're trying to solve for. So the probability that we're trying to solve for is going to be 70%. Then we need to find the value in our normal distribution table that is the closest to 0.7. So we're going to be reading the table from inside out. So what we need to do is look for the value that is closest to 0.7. At what values is it the intersection? So in this case, the value closest to 70 would be this value, 0.7019. And what is it the intersection for? It is the intersection for 0.5 and 0.03. So the Z value that we get from this so the Z value that we get from this is 0.53 because we read the table inside out. So our Z is going to be 0.53. So to find X, we're going to plug in the values into the formula. So X is equal to the standard deviation times our standardized Z value plus our mean, which is equal to 1.5 times 0.53 plus the mean of 11, which is equal to 0.795 plus 11, which is equal to 11.795. Do you guys have any question about this? Always remember that when you're doing the forward backward problem, we always have to get the less than, because the normal distribution table only gives us everything that is less than. You're correct, you could have used a 69.85. You could have. But in this case, we found that 7.019 was closest to 70. Plus the 69 point is close to it as well. Or you want me to go back into detail in how we get the values? All right.
Well,
What's the question?
let's say, picture of bill.
What's the question? I'm not hearing.
Have it down. Can't look on.
Are you hearing me now? Okay. I'm asking you, Alex, what exactly is it that you want me to go back over?
Miss,
Yeah?
that wasn't me, no. I'm asking you to explain how you got the value.
From the table?
Yes.
Okay.
Okay.
All right, so from the table, remember that we had to find the value that's closest to 0.70. As the person in the group just stated, we could have used 0.6985 because when you round it off, it is exactly 0.7. So in that case, but I was just looking for the closest value to 0.70 and I found 0.7019, right? So the first thing we have to do is look for the closest value to 70. And I found that 7.7019 is the closest value to 70. In order to get the Z value, you have to ask the question, what values is 0.7019 the intersection for? So it is the intersection for 0.5 from our y-axis and 0.03 for x-axis. So that's how I got the value of 0.53 because 0.701 is the intersection for 0.5 and 0.03. Did I answer your question?
Yes, miss. Thank you.
All right. And then you just plug in the values into your formula and you get your answer. All right, so this is a comparison between the forward and backward normal distribution. How do you